Good evening, guys. I'm Chris, and welcome back to another episode of Rift Amps. And what a change in the weather. We've got this absolutely gorgeous blue sky weather all week. Much better than last weekend's rain. Anyway, so back on the Cornford, it's pretty much done. I've spent the morning going through it, making some tweaks and adjustments. I swapped out V1. One, because it was slightly microphonic when you turn the thing up, but actually it's made a quite substantial difference to the way this amplifier plays and sounds. So that's good news. I'm 99% with this amplifier now. Most of the issues, or all of the issues that it's come in for, have gone. It just plays and sounds great. And as I said to the customer on the phone this morning, I would now be confident myself to take this out and gig it. So I think it was just in need of a bit of a service and a sort out. So yeah, very interesting and done. So he has asked me to glue back together the cabinet, or at least try and stabilise it the best I can. And then he's away for a couple of weeks, but when he gets back he can come and collect it. But yeah, this will be the last time you see this amplifier. We'll call it done. Sounds great. All sorted. Cornford Hellcat. Right, I've just had this dropped in for repair. This is a Fender 5E3 Tweed Deluxe reissue, the 57 model. And it's come in because there's no output. Customer said he had replaced all of the valves in it. It was running great. He got a couple of weeks or months play out of it, and then he was playing it and it just made some awful noises and cut out and stopped passing audio. It does, however, turn on, and you can hear through the speaker some hum and hiss. So I know the output stage is working. So we need to find out where in this amplifier the issue is. So it's in pretty nice condition, actually. Slight mark on the front badge, but overall the Tolex is in reasonable condition. So I've removed the rear panel just to give this thing a visual inspection, and I can't see anything immediately wrong with it. This is their hand-wired version. Some Sprague electrolytics, a couple of fuses. It's got protection diodes on the... Can we get in and show you? Protection diodes on the rectifier socket. Both screen and grid stoppers on the output valves. You notice that this socket slightly more discoloured than this one. Whether that's an indicator of our issue, we'll find out. But apart from that, I see nothing burnt out. I see nothing immediately obvious. So how are we going to diagnose this? Well, the easiest way, and the way I prefer, is to use what I call the signal tracing method. So we're going to have the amplifier on the test bench, running up to temperature. We're going to inject a signal into the front end, and using the oscilloscope we'll trace it through until we find the point in the circuit where the signal disappears. And if the signal is passing through up to that point, we know those are okay, and the issue must be at the point where the signal disappears. That's one way of doing it. There are others as well, but I'm going to attempt to diagnose this amplifier just to prove that that method is viable. So I'm going to try and do it without using a voltmeter at all. So we'll see how we get on. Just because I won't use a voltmeter doesn't mean I can't use an ohm meter. So before interviews start, all right? Okay, so let's get this thing on the test bench up and running. We'll inject a signal, and then we'll have a look to see what it's doing. Right, so it's on the test bench. I've connected it up to my bench speaker and my switcher box, which switches between the bench speaker and the dummy load. 8 ohms, of course. I connected my signal generator to it, and I could hear the sine wave. the 1 kHz sine wave. So I've now connected my looper to the amplifier, and I'm into channel 1. I've got the volume all the way up at 10, and there is signal passing. I don't know if you can hear it, but it's very low and it's very distorted. So there's clearly something not happy with this amplifier. So our customer complaint that had no output is not correct. There is output, but it's low and it's ugly distorted. Okay, so we need to go further with that. So we'll remove the looper, switch over to our oscilloscope, inject our signal, and we are getting, we're not on 10 times, are we? No. And that is the output, measuring at the speaker socket. That does not look healthy at all. Other channel. Both channels the same. That tells me the issue is after the point where both channels converge. Currently into 8 ohms, 0.1 volts, which is, I can't even measure that, very low. A very poorly unhealthy amplifier. So now we've got the signal running through. Let's bring in our second. So yellow is the output. Oh, what do I do that for? Purple is our second probe. And we'll start off at the input. So we're now connected, and there's our output sine wave. I haven't got the ground connected, so ignore the spikes there at the moment. But we can go onto the input grid of that valve. Let me just connect that up. There she is. And we go to the output. So the anode of that first gain stage, you can see we've got a nice, quite huge, nice level of amplification there, right? From there, so we're tracing this through the amplifier now. We got to our tone controls, our volume control and our tone control, and then it comes back out from that point. And you can see on the purple, the volume control affects the level of it, right? We're just looking at the purple for the time being. From there, it goes into our second gain stage and then out here. And there's our signal. And if I adjust the volume control, you can see that's working fine. Yeah. Lovely. And from there, it goes to the input of the phase inverter, which is this one here. There's our signal. Still working fine. So the input to the phase, all the way up to the phase inverter, is good. Then from the output of the phase inverter, we've got both sides. On one side, we've got a nice signal. On the other side, where are you? There you are. On the cathode side, we've got a nice signal. So now, from the output of the phase inverter is good, and our next stage goes to the input grids of the output valves. I'll just try and get on there. I'm doing all of this live as you see it. There we go. Input to one valve, purple, looking good. Input to one valve. Input to this one, V1, V2, V3. Input to V4, looks good. So up until the output valves, the signal is okay. Now if we measure it on the anodes, the output of V3, that signal does not look good, does it? And the output of V4, again, that signal does not look good. So we've got an issue in our output stage. You see what I did there? I've traced my signal from the input of the amplifier all the way through the two gain stages and the phase inverter to the input of the output valves. The signal is good there, but what's coming out of the output valves is not nice. So now we need to do further diagnostics to see what's going on there. Bad news, I'm afraid. So just to recap, we've got signal coming up to the inputs of the output valves, but the signal coming out is very weak, distorted, looks ugly. We've seen that on the scope. I've just subbed in a replacement set of 6v6s, no change. So I've measured just in case, I've measured the grid stoppers, the screen stoppers, and the cathode resistor for the output valves. Remember, I said I could use an ohm meter, but I couldn't use a voltmeter. They're all okay. So the only thing left at this point that it could be is the output transformer. So I think that's my next direction. So how can I prove that without removing the transformer from the chassis? Lots of various ways to do that, but because I carry a 5v3 transformer on the shelf, what I can do is I can unsolder all the leads, connect this up externally and see if that fixes the issue. So that's what I'm going to do. We'll desolder the output transformer. We will connect up with test leads the replacement and see if we then get the results we're after. And the PR35 US voltage model is done. The customer opted for a very unusual colour scheme of the smooth blonde with the silver grill cloth, amber jewel light, brown plate, but the cream cupcake knobs, and this is a black panel circuit, so bit of a mismatch. I actually really like the way this has turned out. It's almost like a reverse tuxedo look, so yeah, mega happy. Obviously it's got the 2-button matching foot switch, and if I just spin you around, he's gone for the WGS G12C. Back panel, obviously we've got the IEC socket with the fuse holder built in. On-off switch, this is the half power switch. Got our internal speaker socket and one for an external cab, foot switch connection, and the 2 reverb on the back. Pretty standard really, but this one's turned out really nice. I'm really happy with it. Just like the Red Velvet Ainsley Lister, when he spec'd this, I wasn't sure if it was going to work, but actually it does. It's quite nice. It's going to look great on stage. Really happy with this. Just got to box it off, call UPS, and we'll get it shipped over. Right, so I've got the replacement transformer just tack soldered in. The other transformer I've desoldered and just pulled the wires through the back, so there's no chance of anything shorting where it shouldn't be or whatever. Yellow traces the output of the amplifier, purple traces the output of one of the output valves. Ignore the jumping around, it's because I'm not running a ground reference at the moment, but that yellow channel, 10 volts output, 10 times 10 divided by 8 is 12.5 watts. Perfect. There you go. So the issue with this amplifier was a faulty output transformer. So my next job is to remove the chassis, pull the transformer off, and then wire the replacement in correctly. But first things first, I need to call the customer and get approval. Right, so I had a really, really good question about as you know, on our chassis, I have the corners welded up, and on certain models I also have a support bracket for the transformers. And why do I do that? What's the requirement? How does that work? Now, the reason we do that is because part of the testing of an amplifier is to perform a number of destructive and non-destructive tests to make sure that the appliance that you're manufacturing is up to spec and can handle everything that gets thrown at it. So one of the requirements is a drop test. And so here's the regs here, and it says a sample of the completed equipment is subject to 3 impacts that result from being dropped onto a horizontal surface in positions likely to produce the most adverse results. Okay, so what you have to do is with every amplifier model that I produce, I have to perform this test. And the test is literally as it sounds. We have to drop the amplifier onto in awkward positions, basically awkward angles, onto a hard surface, hard floor, 3 times. It's got to survive 3 drops. And here's the rules: the height of the drop shall be either 750mm plus or minus 10, 1000mm plus or minus 10, blah blah blah, depending on the spec. Now, guitar amplifier is classed under movable equipment rather than handheld or portable or transportable equipment, right? Now, movable equipment is something that is moved around on a frequent basis, like a guitar amplifier is. So you might take it from home to rehearsal studio to a gig, back again, blah blah blah. It's not something that's permanently fixed in place, like a photocopier or a microwave might be, for example. Right, so that's the spec that we need: 750mm drop, and it needs to be dropped onto a horizontal surface that consists of hardwood at least 13mm thick, mounted on 2 layers of plywood, each 18mm plus or minus 2mm each thick, all supported on a concrete or equivalent non-resilient floors. Okay, so we're not dropping onto carpet, we're not dropping onto cushions, we're dropping onto a hard surface, right? And we have to do 3 drops from 750mm high, so, you know, what's that, about waist height, roughly, onto those surfaces, and we have to record the test, and we have to check that everything's up to spec and that there's no excessive damage. Now, these chassis are made from 2mm alley, and even with my transformers and everything else loaded on them, and most of the time I hang these from the ceiling of my cabinets, that's the way I like to do them, they pass that test. Up to spec, they pass that test. So we already satisfied that test in the regulations. However, talking to my UPS driver, he said the problem you've got is that 750mm high isn't the same as what an amplifier might fall from on the conveyor belts in the sorting depots. You know, it could literally fall off the back of a truck or off a conveyor belt, and those things can be up to 1 meter or 1.2 meters tall, right? So my rule of thumb is to always, you know, try and build better than what the requirement of the specifications are, right? So now we weld up these corners, and that super strengthens these. So now sorry, I should go back and say, obviously when it's in transport, when it's in the back of a delivery truck or in the sorting depot, it's going to be boxed up, you know, in a cardboard box with foam padding and bubble wrap and all the other bits and pieces. But still, I want, even though that's the minimum requirement, I want to survive more than that, right? So we strengthen these by welding each corner up. And on a model where the combined weight of all the transformers that are mounted is over 6 kilograms, then I add that extra mounting bracket to support it. Okay, so that's the rule. That's why we do it. It's not to meet the requirements, it's actually to exceed them. Right, we've got the go ahead to replace the output transformer on this 5E3, so that's going to be in Sunday's video. But yeah, as I showed you before, we're sticking one of our upgraded 5E3 transformers in it. That's the same one that I use in our Americana model. And over here, just want to show you update on the Swiss Ainsley Lister signature. So I've started wiring everything in. Got my pots in at the front. Got my reverb connection at the back. Cap, chokes wired in, output transformers wired in. Starting to make our connections. I've drilled, punched, and swaged in the eyelet board, and that fits in. It does fit in, like so. So I can get that populated, twisties done, and whatnot. But yeah, good progress on that one too. So we'll just leave it at that. Well, that's it then, guys. Thank you very much for watching once again. This 5E3, there it is. Getting a new output transformer. PR35 is done. Off to North America. The Swiss Ainsley Lister build is ongoing. I'm about to start a PR18 as well. So that's next on the list. The Cornford cabinet, he asked me to glue that back together. So I've injected some glue into the cracks and that's all clamped up. So that's all going to be done and dusted. And that just leaves me to say, please give this video a thumbs up, comments down below, join the channel if you haven't already. These guys have, and I shall catch you all at the next one.